Welcome to This Explainer. Today, we're diving deep into the high stakes of algorithmic decision-making. You know, we live in this era where massive, incredibly complex models are making critical choices for us every single day. But how do we actually know they work? And maybe more importantly, how do we guarantee they're fair and safe? Well, we're going to break down the mathematics of proving a model's performance and then look at the critical infrastructure needed to govern it. To really ground this, we'll be looking closely at the SRBMPR Zero Cycle Behavior Validation Report project, which is a fantastic real-world example of this framework in action.
So let's kick things off with a pretty provocative question. Would you trust a complete black box with your life savings? Or, say, a loan approval? I mean, this really establishes the real-world risks we face when we just blindly rely on AI and quantitative models. Whether we're talking about a trading algorithm executing millions of dollars in split seconds, or a machine learning model deciding who gets a mortgage, the cost of an unexplained error is just astronomical. We absolutely cannot just trust the output. We have to verify the machine itself.
Here is our roadmap for the explainer today. First step, the high-stakes decision problem. Second, proving performance through backtesting. Third, opening the black box. Fourth, explainability versus interpretability. And finally, the AI governance framework. Let's get right into it. All right, Section 1, the high-stakes decision problem. Let's look at exactly why high-stakes environments absolutely demand this dual solution of both technical soundness and complete transparency. Take a look at this. 75% of businesses actually fear that a lack of transparency increases customer churn. The stakes here are just massive. When a model operates as a total mystery, business leaders, regulators, and customers have literally no basis for evaluating if its outputs are fair or accurate. Research shows that 65% of customer experience leaders now view AI transparency not just as some compliance checkbox, but as a core strategic imperative for maintaining trust. Bottom line, if you can't explain it, your users are going to leave.
Moving on to Section 2, proving performance through backtesting. Let's examine how we actually validate these complex financial and quantitative models before they ever see a live market.
Think of backtesting kind of like a medical diagnosis. Just as a doctor evaluates a patient by carefully questioning their medical history, backtesting diagnoses a trading strategy using historical data. You take your strategy and run it backward against past market data, like historical shares of Apple or Amazon, to see exactly how it would have performed. It's essentially a retroactive health check for your algorithms before you risk actual capital. And this perfectly aligns with the core philosophy of the SRBMPR project, which is observe first, interpret later. We have to see the historical facts before applying our theories. Now, when evaluating a strategy's health, these retrospective metrics are absolutely crucial. You're looking at things like the Sharpe ratio for risk-adjusted returns, maximum drawdown to spot the biggest historical losses, the profit factor, volatility, number of trades, and the calm rate. To put that into perspective using the SRB-MBR project, their validation archive utilizes a massive 19,470 candle dataset, extracting 4,513 specific H1 observations just to rigorously calculate institutional metrics like the Sharpe ratio and profit factor. However, it's really important to remember that these criteria don't always give the same result across the board. Effectiveness varies wildly depending on the strategy and the data. So the crucial takeaway here is that looking at just a single metric simply isn't enough. Performance metrics and the number of transactions have to be evaluated together to actually lower your risk. I mean, a sky-high profit factor means absolutely nothing if it's based on just 2 lucky trades over a 5-year period, right? Holistic evaluation is absolutely necessary if you want to make profitable estimations with significantly lower risk.
All right, Section 3, opening the black box. Let's transition from mathematical soundness to visibility. Because honestly, a technically sound model that aces all its backtests can still be a deeply dangerous black box when deployed in the real world.
Let's clearly define what we mean by AI transparency. It's about making an AI system's data, its model behavior, and its decision-making processes completely visible and understandable to affected stakeholders. Transparency spans the entire ecosystem. It's not just the algorithm, it's the underlying data you used, the evaluation metrics you chose, and the governance structures overseeing the whole shebang. It means giving stakeholders meaningful, actionable information so they can actually verify the system behaves exactly as claimed.
Which brings us to Section 4, explainability versus interpretability. These are two completely distinct but equally important concepts in AI that so often get tangled up.
We have to clearly contrast explainability with interpretability. Explainability translates computations into human reasoning for a single output. It answers why. Like, why did the specific output happen? Why was this exact loan denied? Interpretability, on the other hand, exposes the inner workings of the algorithms directly. It answers how. Explainability is for the end user or the compliance officer. Interpretability is for the developer trying to debug the model's inner logic. For a project like SRM-BPR, this relies on a deterministic and reproducible pipeline, governed by strict AI discipline that actually forbids bringing in external, unverified theories. You have to know exactly how and why the model is acting.
And here is a major pitfall you see all the time. Explainability absolutely has to be a design requirement, not a retrofit. You literally cannot just slap an explanation layer onto a black box model after it's deployed and expect it to be reliable. It has to be built into the model's architecture from day one. If you try to reverse engineer trust at the very end of the project, you are going to fail, for sure.
Let's move to our final section, the AI governance framework. Let's see how all of this builds into an actionable regulatory proof of safety.
To actually operationalize transparency and production systems, every single team needs to follow 3 distinct steps. First, create a data sheet for your training data. Second, write a model card for the algorithm itself. And third, log the decision in an audit log for every high-stakes output. That role of audit logs for transparency is exactly how you map AI decisions back to human accountability. Transparency that lives only in a Word document won't survive a fast-moving release cycle. You need these concrete artifacts. Think of this table as your best practices checklist to take back to your teams. Your model card absolutely must document the intended use, known limitations, evaluation metrics, and version history. Meanwhile, your data sheet needs to document provenance, sampling, pre-processing, exclusions, and any known biases. Without these 2 documents in place, your system is essentially unauditable.
But what happens when things inevitably go wrong? Well, governance also requires an incident response playbook, and crucially, this must be defined way before a failure occurs. You need mechanisms to trigger immediate notifications, pull those audit logs we just talked about, rapidly roll back a model if it starts producing biased or unsafe decisions, and rigorously record your mediation metrics so you're continuously improving.
We also have to recognize the massive regulatory urgency here. The EU AI Act directly ties transparency documentation to legal compliance. This is the first comprehensive AI regulatory framework of its kind, so transparency is no longer just a nice-to-have or a marketing buzzword. For high-risk systems, providing sufficient information for users to interpret outputs is literally becoming strict, binding law. So I'll leave you with this final provocative thought to take back to your own organization. Could your current AI and quantitative models pass the strict scrutiny of the EU AI Act? Do you have your backtesting metrics, your data sheets, your model cards, and your audit logs fully in place? Understanding and implementing this trust framework is really the only way forward in an automated world. A huge thank you to the founder of the SRM PRP project, Siabrahaman Gulwadi Abushe, for pioneering this kind of rigorous validation. If you want to dive deeper into their specific framework, you can reach out directly at 786-786-SIAB@gmail.com or call +971 52 950 2833. Thanks so much for joining me for this explainer, and I hope this gives you the tools you need to start building truly transparent systems.